Dear students, I welcome you all to this physics tutorial series of the class 11 physics. I am following the textbook by NCERT for class 11. So in this video, we will learn about acceleration. What is the acceleration? With one example, I will explain you. So in our previous videos, we have learned about average velocity, instantaneous velocity. Okay, so average velocity was the velocity over a time interval, and on the other hand, instantaneous velocity was the average velocity for a infinitesimally small time interval. When this delta t tends to 0, let me write down here, average velocity, the change in position, that is delta x, or we can say it is a displacement divided by the time interval. Time interval means delta t. Delta t expressed as t2 minus t1. Suppose t2 is the final time and t1 is the initial time. So we have to subtract the initial time from the final time, and this is this delta t, and this delta x is, we have a second position, suppose x2 minus x1. This x2 is nothing but this is the final position, x1 is the initial position. So this was the formula for the average velocity. So what was the instantaneous velocity? So if we write here, okay, so here we can write limit delta t tends to 0 when the time interval tends to 0 or the time interval is near 0. Okay, then we have the average acceleration term, that is the displacement divided by the time interval. This time interval delta t tends to 0, that means we have a time interval that is infinitesimally small. So these were the terms we have already learned about the average velocity and the instantaneous velocity. In this video we will learn about the acceleration. So what is the definition of acceleration? It is the change in velocity with respect to a time interval. Acceleration, suppose we denote it with a bar, v2 minus v1 divided by t2 minus t1. So here t2 means the final time, t1 is the initial time, v1 is the velocity at the time t1, v2 is the velocity at time t2. So we have to see whether the velocity is changing. Suppose an object is moving in one direction in case of rectilinear motion, and its velocity is suppose changing. We will take one example, then we will understand how we can calculate the acceleration. Okay, so this is the definition of acceleration. v2 minus v1 we can express it as change in velocity delta v divided by t2 minus t1 we can express it as delta t. This is the change in time. Okay, so v1 and v2, these are the instantaneous velocities at time t1 and t2 respectively. Okay, you have to understand this. Now if we want to find out the instantaneous acceleration, so here we have to put a limit here, limit where delta t tends to 0 and delta v divided by the delta t. Here the time interval delta t, this delta t tends to 0, that means we are considering a infinitesimally small time interval. Okay, I hope you are getting this point. So this was the instantaneous acceleration. In case of acceleration, we have to see the change in velocity. In case of acceleration, we are considering the change in velocity with respect to the change in time. Or in case of instantaneous acceleration, this delta t tends to 0. Okay, so in this way we can find out the acceleration. Now let us consider one example. So these are the two figures from your textbook. So in the first figure we can see that an object is changing its position and its velocity is also changing. So here you can see this velocity is increasing gradually, okay, up to here, and then it is remaining constant. Okay, then it is remaining constant, and then it is again the velocity is decreasing. Okay, along the y-axis we can see the velocity in meter per second. Here in this x-axis we have the time. So in the left hand side of this graph we can see this is the time. Now to understand the right hand side figure, so now suppose to understand this figure, we have to see some points from this left hand side figure. From 3.7 we have to see some points. Suppose from 0 to 10 seconds, here we can see from 0, so from here to here 0 to 10 seconds. So up to this point we are considering. So from 0 to 10, what is the acceleration? It is increasing 0 to 10 second. Okay, what is the acceleration? Acceleration is suppose a bar because it is a vector quantity. So what will be the acceleration? It is the change in velocity with respect to the time interval. Okay, so change in velocity means from 0 velocity it is arriving here at suppose 24. This point is 24. Okay, so here we can see this 24 will be the final velocity, that is 24. What was the initial velocity? It is 0. Here minus 0 divided by the time interval. Time interval is from 0 to 10. So this time interval is 10 seconds. Okay, so what is the acceleration? 24 divided by 10, so it will be 2.4 meter per second square. Okay, so this is the acceleration for 0 to 10 seconds. Now let us consider from 10 to it is up to 18. Why we are considering 10 to 18? Because from here we can see the velocity is not changing, it is constant at 24 meter per second. Okay, from 10 second to 18 second. So what will be the acceleration? Acceleration is equal to, so the final velocity is 24 at this point. We can see at this point 24, and at the initial point also it is 24. So 24 minus 24, what is the time interval? From 10 to 18 we have, it is 8 seconds. Okay, divided by 8. So 0 divided by 8 is equal to 0 meter per second square. So what we can understand from here? So here we can see that the velocity is constant from 10 to 18 seconds. So the acceleration is 0. There is no change in velocity. So acceleration is nothing but the change in velocity over a time interval. Okay. Now let us consider the final point. From 18, this point, let me show with red color, from 18 second to 20 second. Okay. So here we have to see 18 second to 20 second. What will be the acceleration? Acceleration is the change in velocity divided by the change in time. Change in velocity means from 24 it is coming to 0. Okay, so what will be the value here? 0 minus 24. So the final velocity is coming to 0, because you can see at 20 second we have 0 velocity. This is the 0 velocity here. And what was the initial velocity? Initial velocity was here 24. Okay, so at 18 second the velocity is 24. What is the time interval? The final time is 20 second, initial time is 18 second. Okay, so what will be the acceleration here? Minus 24 divided by 2. So what will have here? It is minus 12 meter per second square. Okay, are you getting my point? Here the acceleration is negative. This means the velocity is decreasing from 18 second to 20 second. Okay, and from 10 to 18 second it is 0 meter per second square. There is no acceleration, velocity is constant. From 0 second to 10 second we have this much of acceleration, that is it is a positive term. So the velocity is increasing from 0 second to 10 second. Okay, I hope you are getting this point. So from 0 to 10 point, this one is the first case. From 0 to 10 second we have 2.4 meter per second square. This is a uniform acceleration, so it is increasing at a rate of 2.4 meter per second square. And after this point, from 10 to 18, or we have a 0 acceleration. So the acceleration graph along the y-axis we can see here, this is the acceleration graph along the y-axis. So from 10 to 18 we have, this is 0 acceleration, so there is no velocity change we can see here in this point. Okay, so and in the last case it is minus 12 meter per second square. So here we can see from 18 to 20 point, here you can see, let me show you with another color. From 18 to 20 we have a minus 12 value of acceleration. Now I hope you understand this point. What is acceleration? How we can calculate when it will be a retardation? Actually, whenever we have acceleration has a negative value, then it is called as a retardation. Okay, I hope you are getting this point. So what was the acceleration? It is the change in velocity with respect to change in time. In case of instantaneous acceleration, we have change in velocity over change in time. when the time tends to 0, that means the time interval is infinitesimally small. So this much for today. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.